In this video, we have a 2013 Malibu instrument cluster, but this instrument cluster is a previous repair attempt. So what I decided to do with this video is we're gonna go over some common mistakes and things to watch out for. So let's get started. Let's just take a quick look around the unit. I see, yeah, there's a tab broken off here. This tab has been overextended. As you can see, it's about to break. There's not much holding that one. See if there's any other tabs missing. Okay, it looks like, yeah, this one here and this tab here are broken off, and this one's about to break. All right, and there, take a look at the LCD. Definitely tell someone has been in there. I don't know if I can get it in the light just right, but the LCD screen has quite a bit of finger marks on it. So when opening these up, you want to be real careful on not bending these clips farther than they need to go, because as you can see, they do and will break if you try to overextend them. So you just want to, unclip it just far enough to get past the little hook ridge, but don't go too much farther past that. Okay, so yeah, we got some scuff marks and stuff on the face. That's why I like to lay like a cloth down before popping the needles, just to avoid, oh, that should have some resistance. So okay, so these motors are good. These have resistance. This one's good, but that, it should not do that. So what we have here, this version of stepper motor, if you put too much force on spinning the shaft, there's a worm gear that pops out of place. So we'll cover that later in the video on how to repair that. So this is repairable. This would have never have worked. Their mile per hour is busted. So we'll take care of that. And then here we'll give the LCD screen a good wipe down because it's still a little full of fingerprints. Okay, so here let's try to get this back plastic off maybe. See if I can do this without damaging any more of the clips. Okay, so here you can see we're down 2 tabs, and this one's about to break. Not really a huge deal, but I always try, when I do this with my customer units, I always try to be careful to not bust those off. Now to get the needles off, I usually use my small US Speedo branded needle puller, but I broke the last one I had, so I was stuck using this giant thing. Prefer the small one, a little more nimble, but got to make do with this for now. I sent an email to US Speedo asking if they would sell me maybe like a half a dozen of those, and they ghosted me. They didn't reply. So, oh well. So notice with these stepper motors, I'm not putting a whole lot of twisting, braking force. With like the other GMs, if you give a little tweak past the stopping point, it helps break them free. But with this stepper motor, you just kind of want to go straight up, otherwise you end up with broken stepper motors. And more clips that you want to try to avoid overextending, because these can break off too. Okay, the board is free. Okay, and this is the area here that gives these things trouble. And the resistor is missing, which the customer did warn me that the resistor fell off and he lost it, so we can take care of that. But the board looks clean. There's no pulled pads or solder goopers or anything, so this must have happened early on in the repair. It must have lost the resistor and packed it in after that, which is nice for me because I get to work with a clean board. Let's get this up on the microscope. My microscope camera just kicked the bucket. I've got power coming in. I tried a different AC adapter. I tested this AC adapter, but it's refusing to turn on. So today's footage is not going to be very good, but I'm going to try my best to prop up a camera so you can see what I'm doing. And part of the struggles with, doing the Malibu cluster is it's hard to really tell just how small the parts are. That's, oops, focus. That's the part we are need to install, and it's hard to work with. It's hard to do. It's microscope work, but let's get started. Before we put that resistor in place, back in place, I'll just show you what it does. It's not going to power up, but let's just go ahead and give it some juice, and we will see. We will confirm that it definitely is not going to work. And the power supply's on, 13.6 volts. It's pulling a tiny bit of current, but she's dead. No life. So let's go ahead and take care of that R203 now. Unfortunately, I'm not able to see what I'm filming, so I have no idea if this is going to stay in focus while I work, but I'm going to do my best here. I'm just going to tin up the pads a little bit, get a little fresh. Oop, there is a missing pad. Yep, there was a pad that came off, and you probably can't see it. And I wish my microscope camera was working, but I'll have to do a little reconstructive surgery on the pad there. But the part that's missing is a 1.2K resistor, and let's go ahead and get that back on. Here I'm just running jumpers to the resistor. I'm using lamp leads because I have an unlimited supply of lamp leads. They make nice jumpers. I am going to jumper both sides of the resistor because they do have weak pads going to this resistor, and I've seen them fail even without human force. They are known to fail. So, all right. I'm just going to clean off my flux with a little ISO, a little scrub. All right, can we get a focus? Focus. Here is the new resistor, and you can see I got a jumper lead on both ends of it. Give it a nice solid connection that will not fail like the original foil or the original solder joint. That leaded solder makes a nice difference too. Anyways, it's installed, it's clean. Let's see if it powers up now. Power. And just wait a few seconds here, and it should boot up. Yeah, there we go. All right, that part's done. Next, let's take care of this busted stepper motor. So this is the mile-per-hour one here. This is the, whoops. This is the one that just free spins. And if I boot it up when it does its little sweep, it might make some clicky noises. Yeah, you hear that? It's ticking. That ticking sound will go away once I get the gears meshed back into place again. But yeah, it should be zeroing out right now, doing a little sweep, and it's not moving. These stepper motors, they're not soldered in. They just have these little pins you got to push in to release them. So one pin is there and one pin is here. And you just push those through and back, and then it should just pop out. Okay, so there it is. Next, I'm going to show you how to open this thing up and fix it. You do not have to replace it. You can actually fix it. So there's two melted tabs that stick up through the plastic, and they just melt the tops down to kind of keep it from popping apart. There are clips around the edge, but they it's kind of like a secondary method to keep the motor together. But we're going to go ahead and kind of squish the melted tab back up so I can slide these pieces apart. Okay, so I think I have those up and out of the way enough that I can get it apart. These tabs here can stay. That just holds the motor to this half of the case. So the only ones you have to release are just these plastic melted tabs here. And now it should pry open without too much effort. And plastic tabs are still got a bit of a bite. Try not to booger up that gear in there. There we go. Okay. So here's the worm gear I was talking about earlier, and it just pops out of its little, I don't know what you call it, bearing carrier, I guess you could. Not, it's not a bearing, but it's just a little notch for the shaft of the worm gear to sit in. And when there's too much force, so when the previous repair attempt was removing the needles, they put too much of a spin on it, and that popped the gear out of its little holder there. So that's all we gotta do is push the gear back in. But what I like to do to make sure it doesn't happen so easily or pop out while I'm working on it, I'm just gonna kind of put a little bit of a, see if I can get it focus on here, just a little tiny bit of a lip on the edge with my soldering iron, kind of melt it over, and then the other end too. That kind of helps lock it in place. Now it's not holding the shaft from spinning, it can still spin. It's just less likely to want to pop out. So now we can see the gears are aligned, and we can put it back together. Okay, snap back together. I'm just gonna put a little mush back on top of the little plastic locking tabs there to hold that down. Okay, no one will ever even know we were in there. Click that back in, and then you just push these little locking tabs back again. So you want them, yeah, flush, just like that. So these little locking nibs kind of are about the same height as the ones that we didn't mess with. So, all right. And now we should have a working mile-per-hour stepper motor. When it boots up, it should do a sweep. Power. There we go. And that should. All right. Okay. Back in business. The clicking sound is gone, and it is nice and smooth again. Now to do something about all the fingerprints on the LCD. Yeah, that looks pretty good. I'm happy with that. The reassembly process, we're going to start with the face half, and the circuit board just clips into that. And again, when doing this kind of work, always be mindful of where your fingers are, so you're not touching the face or the LCD screen. I always like to try to keep those nice and smudge free as much as I can. Okay, that's all clicked back in. Now we put the back back on, and this clip here, I don't know if she's gonna survive much longer. I'll see if I can help this one out a little bit. Okay, let's see here. Right about there's where it should be. Okay. Now that clip is straight again. Give that a minute to dry. Oh no, the tab didn't hold. Ah, that stupid tab broke again. All right, well, you know what? We don't need that one. All right, now to set the needles. All right, looks like I need to make an adjustment to the mile per hour. It's a little bit under. With this model, the home position is right at the first 0 dash mark. I just have to wait for it to 0 out again, get back to the home position. All right, yeah, looks like that's better. I'm gonna try one more test sweep. Okay, that looks like pretty good calibration, and the needle height is good too. All right, so this video's tips for the do-it-yourselfer. First tip to watch out for is don't overextend the clips when you're taking the plastics off, because they will break. When you're removing the needles, use a cloth under the surface of the tool so you're not scratching up the face. When removing the needles, don't over torque them on this model, because then you have that worm gear jumping out of its holder. Be cautious of where your fingers are. Some of these matte finish faces, once you get a fingerprint in there, they're in there for life. You can't get the oils out of some of the matte faces. And if you drop this resistor in the carpet while trying to resolder it, it's gone forever. So buy yourself a 10-pack or something if you're going to go through this cluster. I think that about does it. These clips just here need a little extra pop. All right, I think that's it for today. Oops, I'm shorting out my power supply. We're gonna do one more power cycle boot here. Okay, we're good. Thanks for watching.